Welcome back to our channel, where we explore the fascinating world of electrical engineering. In today's video, we will dive into the topic of protection zones and backup protection of a transmission system. Specifically, we will discuss the four important zones of protection: the busbar zone, the line zone, the generator zone, and the transformer zone. So, let's get started. Before we dive into the details, let's have a quick overview of the purpose of protection systems in a transmission system. The primary function of protection systems is to detect and isolate faults or abnormal conditions that may occur within the power system. These faults could lead to significant damage or even complete failure of the equipment and, in some cases, pose a threat to human safety. To mitigate these risks, protection systems are installed to ensure a reliable and secure power supply. Let's begin with the busbar zone. The busbar is a crucial component of a power system that connects various devices such as generators, transformers, and transmission lines. In this zone, the primary protection scheme focuses on detecting and clearing faults that occur within the busbar. The primary protection for the busbar zone is typically implemented using differential protection. Differential protection measures the difference in currents entering and leaving the busbar. If there is a significant current difference, indicating a fault, the protection system will act to isolate the faulty section from the rest of the system. Additionally, backup protection schemes such as overcurrent and distance protection may also be employed in the busbar zone. Moving on to the line zone, this zone deals with faults that occur on transmission lines. Transmission lines are vital for transferring electrical power over long distances. Due to their exposure to various environmental conditions and external factors, faults can occur, including short circuits or insulation failures. The primary protection scheme for the line zone is typically distance protection. Distance protection measures the impedance or distance to the fault location. By comparing the measured impedance with predefined settings, the protection system can determine the approximate fault location along the transmission line. Once the fault location is identified, the protection system isolates the faulted section while keeping the rest of the system operational. As a backup, overcurrent and directional overcurrent protection may also be employed in the line zone. Let's now explore the transformer zone. Transformers play a crucial role in stepping up or stepping down voltages in the power system. Faults in transformers can have severe consequences, including damage to the equipment and disruption of power supply. The primary protection scheme for the transformer zone is typically based on differential protection, similar to the generator and busbar zones. Additionally, backup protection schemes such as overcurrent and restricted earth fault protection may also be employed in the transformer zone. Lastly, let's discuss the generator zone. In this zone, the protection system focuses on safeguarding the generators, which are crucial for power generation in the system. Faults within generators can lead to severe damage, and the protection system should act swiftly to prevent further issues. The primary protection scheme for the generator zone is typically differential protection, similar to the busbar zone. Differential protection measures the difference between the currents entering and leaving the generator. If a significant current difference is detected, indicating a fault, the protection system isolates the faulty generator from the system. As a backup, overcurrent and stator earth fault protection may also be employed in the generator zone. These backup protection schemes provide additional layers of security and detect faults that the primary protection may fail to capture. These backup protection schemes provide an additional layer of security and ensure that faults are cleared even if the primary protection fails. And there you have it. We have explored the 4 crucial zones of protection in a transmission system: the bus bar zone, the line zone, the generator zone, and the transformer zone. Each zone has its specific primary protection scheme, along with backup protection schemes to ensure reliable and secure operation of the power system. It's important to note that these protection zones and schemes can vary depending on the specific requirements and characteristics of the transmission system. We hope you found this video informative. If you have any questions or would like us to cover more topics related to electrical engineering, please let us know in the comments below. Don't forget to like and subscribe to our channel for more exciting content. Until next time, stay curious and keep exploring the world of electrical engineering.